Hello there and welcome to SNMB Academy. Now, let's talk about atoms. An atom is the smallest particle of an element. Literally all substances, everything we see around us are all made up of atoms. They're literally very tiny, impossible to see with our naked eye. And actually sometimes it even makes it very hard for us to see it with a microscope. So you can imagine how tiny they are going to be. You have so many examples. You have millions of examples of atoms, and the best ones that you can actually find are in the periodic table. So any element you pick from the periodic table would be made up of atoms. So an hydrogen atom, or a chlorine atom, or bromine. So they all are made up of atoms. So in front of you here is a diagram of an atom, the best one I could see. I chose to first initially draw it myself, but that was coming out completely hideous. We cannot present you with that now. So by the looks of this diagram, you're probably thinking how it looks for the ones who have never seen a structure of an atom before. Now everything in here is a representation of something. It stands for something. So let's just start off with this line over here. Now this line, we call it a shell or shells. Okay, shell is the outer layer of an atom. Starting on this blue dots that you see in the shells are electrons. An electron is one of the subatomic particles of an atom. Now, inside this part, that is all a nucleus. Usually to show that's a nucleus, they usually draw this like in a bag like this that represents that this is a nucleus. So let's just call this a nucleus. And inside the nucleus, you can see that we have two different colors. You got a red and a yellow. Now these two are the other two types of subatomic particles along with the electrons. And one of them would be the protons, while the other one would be the neutrons. So let's just say, let's just call the yellow ones neutrons. And the red ones would be the protons. So those are five initial things that we should know in the structure of an atom. So we have the shells, the electrons, we have a nucleus, and inside the nucleus are the neutrons and the protons. Now, the electrons are basically orbiting around the nucleus, just like the planets orbit around the sun. And while the neutrons and protons stay inside the nucleus. So there are different ways. Over the years, hundreds of years, over the years, the structure of an atom has changed. Different scientists came with their own theories, and different types of structures of an atom, emerge out. While today, in today's day and age, in the modern era, we use this as a structure of an atom to understand it better. You can find different pictures of an atom, different structures. I have got a couple of pictures here to make you understand. So they're exactly the same thing. So we have a nucleus, this great thing, and then we got two color circles inside. So one of them are the protons and the other ones are the neutrons. Why do we have the shells? Now they are different shells. You're probably thinking why the different shells, but they're shells that are outside like rings around the nucleus, and within those shells you will have electrons that are completely orbiting the nucleus. Now shells have their own orbits, as you can see here, but we don't want to get too much into it. We just need to understand this diagram first, making sure that we understand where each of the subatomic particles lie. Now moving on, what we actually need to know is that for each of the subatomic particles, we actually need to know a few things about them. So I've just got a table here to make it better for us to just help us understand a lot better. So we've got subatomic particle. Now the three subatomic particles we've already know. Number one would be the protons, and then we have the neutrons, and lastly we've got the electrons. Now, the three things that, in the examination, what they mainly ask are the charge of the subatomic particle, the mass, and where exactly in atom do they lie. Now, starting for protons, the charge would be either positively charged or negatively charged, or it would just be neutral, one of the three. Now, protons are positively charged, so he has a charge of +1. And the best way to remember them is for P for positive, P for proton. So it has a charge of +1. Neutron has a charge of 0, and you can remember that with the word neutral, it's just 0. And moving on, the last one, electrons are negatively charged. Now we just know electrons, electricity, anything got to do with elect, that's all negatively charged. Now moving on to mass. Now, one thing we need to understand is that all subatomic particles are really, really tiny because they are all part of an atom, and atoms are very tiny. However, protons and neutrons are relatively higher in mass compared to electrons, and the reason for that is because they are inside the nucleus. So the mass of proton we say is 1. And neutrons, we also say the mass is 1, because both of these subatomic particles lie within the nucleus. However, the electrons are around in the shell, so like we've seen here. So the electrons are around inside the shell, so they're not inside the nucleus, they're further away from the nucleus, they orbit around the nucleus. So their mass is actually really, really tiny. So the mass of an electron would be 0.0005. So by looking at it, we know that if we have 10,000 electrons, that's equivalent to just 1 proton or just 1 neutron. So we can imagine how tiny electron is. So comparatively to comparing protons or neutrons to electrons, we can see that, okay, they're quite heavy in mass compared to electrons. Now, where exactly do each of these subatomic particles lie in the atom? So we know protons lie in the nucleus. Then we have the neutrons that also lies in the nucleus. And then we got the electrons, which lies in the shells. Now, a lot of students, a lot of people as well, they get confused in just saying electrons are in the outer shell. They're not only in the outer shell, they're in all the shells. Now, this is an outer shell, right? And this shell is the inner shell. Now, both shells have electrons. So electrons are not just in the outer shell, they're literally in all the shells. So we just need to understand that concept as well, making sure we know that where exactly electrons lie, in all the shells. Now, what we have is, if we have any atom, the two things that we actually need to know that describes an atom is, number one, we have the atomic number. And the second thing that we need is the mass number. Now, these two things are very well presented in the periodic table. So let's just pick any one element from this periodic table. Let's just say we pick sodium. So sodium is displayed like this. So we have the symbol inside for sodium and A. We have the two numbers, right? That's 23. And then we have the other number as 11. So you probably might have guessed that one of these numbers would be the mass number, one of these numbers would be the atomic number. Now, in many periodic tables, they only just give the mass number, or sometimes the numbers are swapped. So 23 might be at the bottom, 11 might be at the top. So in either way, it doesn't really matter. We just need to understand which one is which and how do we know it. The higher number will always be the mass number. That's the way to remember it. And the lowest number will obviously be the atomic number. Now, what are the definition of each of them? Let's start with the atomic number. Atomic number will be the smaller number. So that's 11. That's the atomic number. And what is the atomic number? What does it mean? So atomic number is the number, it shows us and tells us the number of protons. And then the top number we have 23 would be the mass number. And what does mass number tell us? The mass number tells us the number of protons plus the number of neutrons. So the mass number tells us both the things. It tells us the number of protons plus the neutrons. So the atomic number has already told us the number of protons. So using the mass number, we can find out the number of neutrons only. So all we have to do is 23 take away 11, and that gives us 12. And that 12 will be the number of neutrons, because we know that 11 is the atomic number, which is the number of protons. Now, I know what you lot are thinking. You lot are probably thinking, okay, we got the number of protons, we've got the number of neutrons. What about number of electrons? Number of electrons is not suggested within the box, because we know that one thing we need to remember is that the number of electrons are always the same as the number of protons. So whatever atomic number, whatever the number of protons there is, that's the number of electrons that will be. And that's only just inside the atom stuff. An atom has an overall charge of 0. But if we talk about ions, that's different. So we're not going to talk about ions right now. So let's just have a look at each one of the subatomic particles, the number of them. So we've got the protons, we've got the electrons, and then we have the neutrons. So number of protons, we know that's the atomic number, which is 11. Number of electrons, we know number of electrons are exactly the same as the number of protons. So protons is 11, electron will also be 11. And number of neutrons would be my mass number, take away my atomic number. So 23 take away 11, and that's 12. So sodium has 11 protons, 11 electrons, and 12 neutrons. And this thing, when you find out the number of protons or the amount of any subatomic particle, you can apply this to any element of the periodic table and find out how many of each subatomic particles there are. So very nice and easy. Just a matter of time that we learn things, we just know how to do it, to be honest. That's the main thing. That's literally it. So guys, thank you for watching. Do not forget to subscribe to our channel to keep updated for more content. Thank you.